Hello, everyone. I'll introduce myself briefly and what I do. I go by dcbuilder online on Twitter or on X and other places. I'm a research engineer at the World Foundation. As a show of hands, how many of you have heard of World before? The orb, WorldCoin, formerly known as WorldCoin. Okay, I'll introduce it from just first principles very quickly. So on the internet nowadays, it's really hard to tell apart what is human, what is not human, like what is AI, what is not human, because AIs and like large language models and generative AI has become so good that it's really hard to distinguish AI from bots. Some of the things that we're solving is creating a proof of personhood online, so you're able to prove that you're a real human being when you're using applications, whether they're websites or blockchain applications like smart contracts. And for that, we built this hardware device called the Orb, which is able to prove that you're a real and unique human being by leveraging biometrics, specifically irises and iris codes, and cryptography to make it fully privacy preserving. And so over the last sort of year or two, I've been working a lot on sort of the intersection of AI, cryptography, blockchain development, things like that. And so through thinking around things like the application of cryptography within the context of machine learning and AI, one of the things I worked on was zero-knowledge machine learning, which is creating zero-knowledge proofs of the execution of machine learning model inference. Over time, as sort of machine learning, just the general AI space has been evolving, we've seen a lot more need for better data pipelines, better identity systems within agents, and delegating identity to agents. So this is sort of what I'm going to be talking about today, right? So agents and identity. So what is an agent? I feel like many of you have an intuitive sense for what an agent is because you've maybe used ChatGPT, or most of you have used ChatGPT or other similar products. So an agent is something that has intelligence, it has reasoning, it's able to think about specific problems and give you an answer or a solution. It has access to tools. So tool use just means that you're using, for example, you can generate code and you can execute that code on some machine, and the LLM has direct access to that. If you're a developer, you may have used Cursor, Lovable, Windsurf, any of these AI editors that allow you to just write code and then execute it on your machine. Right, so these LLM agents, some of them have access to things like browsing on your browser, right? Like they can use Google Chrome, or they can use some API. They can fetch information from the internet, right? They can do search. They can search, get internet data into their context window, and then evaluate with recent data, right? They can generate images. They have a plethora of tools they can use to do different things. And they're also autonomous or adaptable. Currently, they don't have autonomy whatsoever, or at least not in most products that are live out there. Mostly because it's really hard to get autonomy right for agents, right? They can go and do something you don't want, so you want to stop them. Maybe we have like really limited independence in agents from, I don't know if you've seen products like OpenAI Operator, which allows you to do like browsing, let's say like DoorDash, and order some food to your place. So if you generalize this, not just to like a product, but like just as a technology, this is in general like what an agent is. The problem, or some of the problems that these agents face, is that it's really hard for you as an application developer, or builder, or service provider to actually let these agents operate on your website in a way that doesn't break your service, right? Like if I'm a malicious actor, a malicious agent, I'm able to spam your website with invalid requests or do wrong things that then make it really hard for me to provide service to actual humans. Maybe you can gatekeep it by like, okay, you have to pay some money to use it. But even then, for example, if you take the example of X, there's lots of bots paying for premium badges to post misinformation or do all sorts of different things for spamming the network. So another one is discoverability. Right now, agents are sort of mostly on the user side, where the agent does something for you, but the agent does not really engage with other agents to discover what sort of best service or best product you can get for some intent. If I want to get something, then usually it's a predisposed or pre-selected set of APIs or things you can use to get it. Like on OpenAI Operator, you need to get an integration with DoorDash specifically. There's not another agent on the other side talking to your agent like to realize like some goal. And also composability. This is like a general problem of Web 2, where all of your personal data, as was mentioned in the previous presentation, was that all of the data is siloed within Google, Facebook, Meta, Amazon, all of these big data players, and that's their moat, right? Like they have your data and they're able to advertise to you to monetize your data essentially. The problem is that if all of your data is siloed, then you cannot give it to an agent in a cohesive way so that it can act on your behalf and use that information to prove to somebody else that you're worthwhile of being provided a service, or like you can get discounts or product targeting. So let's say, for example, I am a power user of Uber Eats, and I've ordered like over 100 Uber Eats orders. I could get a discount from, let's say, DoorDash because I'm a Uber Eats power user, but nobody really knows that. Like I cannot prove it because I cannot connect my Uber Eats API, if there was one, to actually prove that to the other agent. So what I believe is that if you have a cohesive identity framework that is actually verifiable and you give that to LLMs or agents on your behalf, you can build lots of really cool solutions. So this is sort of the general diagram I created, right? So you have a lot of sources for these data, right? Like you have your own personal information, like KYC, my name, surname, birth date, my emails, my SSOs, my single sign-ons, so like Google Auth and things like that. My on-chain data, right? Like I've interacted with XYZ smart contracts, like I don't know, I've borrowed, I've traded this much volume. That is like useful information for things. Proving my personhood so that I know that it's one person, one action, and one person, one like set amount of actions. So you have SIB resistance or rate limiting. Web data, right? This is what I mentioned earlier, where you have like information across all the services you use online, but you cannot really give that to LLMs. And over the last couple of years, there's been this really important tool set which allows to free that data and make it self-custodial. So instead of me having to prove to everyone or like custody all my data in third-party APIs, I can hold it myself. But now people can trust me because that data is somehow authenticated or signed. So if I have signed information from all the services I use, then I'm able to create proofs of disclosure of that data, and those proofs are actually verifiable by the third party, so they know that I've actually done more than 100 orders on Uber Eats, or that my nationality is this, or that I'm a unique human and I've not done this action before. Once you have this sort of programmable cryptography tool set, which uses the technologies I mentioned above, like zero-knowledge cryptography, multi-party computation, fully homomorphic encryption, trusted execution environments, you can do things like web proofs, ZK email proofs, ZK identity proofs of your passport, proofs of personhood with World ID, for example. And if you give all of those tool sets to agents, they can act on your behalf in a way where the services and products that are provided by the third party are actually verifiable. And you know what you're getting, and they know what they're getting. So you're able to monetize it much better because you can keep it private, and you can selectively disclose only the things you need, and everyone wins at the end of the day. I feel like the problem with, let's say, the previous approaches is that you're trying to villainize the Googles and Metas of the world. They're not trying, like, of course, like they need to have the data for making the business, but if they could do the business without the data liability, they would do it. It's just impossible to do it right now in any other way. So something that would be great is if everyone could hold their own data and then just selectively prove to the third party what you need to do. And so this is sort of like why I believe that identity is the missing link so that agents can actually act on your behalf for using all these products and services across the internet and Ethereum and other places. So I mentioned this thing called programmable cryptography, or why I think it's important. So the things that it solves is, I've been talking about this, but I want to like illustrate the points individually. One is privacy, so I can hold my own data in an encrypted fashion and then just selectively disclose things with zero-knowledge proofs or a trusted execution environment signature. Right, so I keep my ownership of my own data, and I can monetize that. I can be the beneficiary of my own data. Composability, right? So like I had this data siloed in all these other services, but now I can compose them, put them together, and do an actual application with them across like all these services. They become just like all these siloed APIs. They become part of the agent and the access space of the agent, so they can do anything with going from one to the other, if you have like intelligence, right? So SIB resistance, this just means that I'm not able to spam a service. I'm able to actually know like, hey, if I get a free tier for an API, I can get much higher rate limits, and I cannot abuse it in any way, for example. And this is a big problem because like Google, Meta, and all these companies, they spend billions of dollars in just paying for bot use, right? Like they have this churn, unfortunately, where they lose a lot of revenue because they're actually interacting with bots that are abusing their services. So if you had a way to mitigate that, you'd have much better profit margins, right? You don't have to churn as much money because you know you're actually interacting with a real human being that meets some threshold. You can better target, you can better get access, you know that you're not getting abused. All these properties are really important when building products online. Discovery, right? So agents are smart, they can discover things for you, they can interact with other agents, they can negotiate. Verifiability, so you know that these things are actually happening through ZK or MPC or trusted execution environments. And you have autonomy, right? Like as these systems become more independent and you have like the next wave of agents that are actually more independent, they can act on their own and they satisfy the benchmarks like RKGI2 and all these like agent benchmarks and internet and tool use benchmarks. As they get better, then all of this just becomes a lot better. And if you give them identity, it goes to a whole new level. So this is the practical example I was just mentioning earlier with the Uber Eats side, right? Like I'm able to prove to DoorDash that I've done more than 100 Uber Eats orders and they can target me a lot better. And instead of me having to do all of these proofs, I can just delegate my identity to the agent and the agent can selectively disclose things about me to the third party and they can just do all this autonomously without me having to interact. So the end product for me is that I get much better product and services without the effort and I keep owning my data. So I have full privacy, full autonomy, and everything is much better for me and also for the application provider because they don't have to churn as much. So if you actually wanted to build something like this as a developer, what sort of tools can you use today to build them? So for agents, there's a plethora of different tools. There are some closed source or API-based ones like OpenAI's Responses and Agents SDK, where you can interact with an API. There's ones you can fully self-host on your computer, like LangChain, CrewAI, AutoGen. Also, there's the Coinbase team built Agent Kit, so you can interact with things like smart contract wallets and other things. For identity, there's tools like ZK Email, which allows you to create proofs of your email data. There's World ID, which allows you to prove things about your you're a unique human being. And also, we have this feature called World ID Credentials that allows you to do selective disclosure of passport credentials, for example. There's Pluto and other web proof-based tools. These allow you to create proofs of these like internet tool uses, right? So there's, for example, in the Aguilar ecosystem, there's ones like Reclaim and others. So you're essentially able to prove anything about your internet data. ZK Passport, this one is a bit self-explanatory, but essentially you're able to selectively prove that I'm over a certain age, like I'm over 18, I'm from this nationality or set of nationalities. Or I've traveled to XYZ places. As long as you have a verifiable way of proving these things, then you can have more data for your identity protocol. The next one is Axiom or Herodotus. This means that you can create proofs about your on-chain activity. Axiom and Herodotus are startups that allow you to do storage proofs. So you can prove any state included in, let's say, the Ethereum storage trie or like any L2 or other L1s. For TEs, there's lots of different tools. So Intel SGX is a hardware-based tool. Essentially, it's a chip that is in specific servers you can have to have integrity of the execution of a computer. And this is a hardware-based sort of verifiability tool. There's TDX, which is used by teams like Flashbots. SGX is used by teams like Automata. And there's a bunch of different tools. I recommend you like just look through them and pick the one that feels better for you. When it comes to smart contracts, I mean, I feel like anyone in the blockchain space has heard of Solidity. And you can build applications with a bunch of these different tools. I mentioned different ones for different environments. For ZK, one of the ones that is becoming really popular is Noir. Noir is a domain-specific language for writing zero-knowledge proofs and circuits. And if you don't want to learn a DSL, you want to use something you're familiar with, like Rust or some other programming language, there's these ZK VMs like SP1 and RISC-0, which allow you to create proofs of regular programs. For platforms, like where do you want to deploy your application? Many of you have probably built a web app or some mobile app before for Android and iOS or just like a browser app. But one of the things I wanted to mention here is that we at World have World App. World App is a phone application that is downloaded over 25 million times across iOS and Android and has over 12 million users that are verified by the orb. And we have this feature called mini apps, which allow you to build applications on top of World App. So if you're an app developer and you want to get access to real consumers, you can build it on top of World App, right? So you have a web app that it shows as a web view within World App, and you can get access to all of the World App users and the APIs from the app, right? So you can trigger things like payments, you can trigger things like verifying your World ID and proving you're a unique human, and plenty of other things like push notifications and other quality of life tools. So this is just something I was showing earlier, but yeah, this is sort of what I wanted to talk about today. The world would be much better if you had agents that had access to like real identity. It's already like something we're trying to do before, like give humans access to provable identity. But I feel like agents are the thing that are going to drive the point home, because before, when agents weren't a thing, like we were already thinking like, okay, how can I create proofs of my identity to other people? But this doesn't scale, right? Like the internet is becoming a much more fast-paced place where like transactions flow much more rapidly, and it's really hard for humans to like keep up, right? So like agents and identity sort of solve all of these things that I believe are going to be really important to build sort of the new wave of products and services for people. Okay, thank you everyone for listening. So this is my my Twitter and the WorldCoin's Twitter, or the World's Twitter. And if you have any curiosity and like want to learn more about like what World is about, you have our white paper or just our landing page. So yeah, thank you everyone.
Do you want to take a question? If there's any question. 혹시 질문 있으시면은 any questions for DC Builder?
I have the cam.
You already got it.
You take it back for me last time, so they're all my questions as long as I have this. I had a question because, obviously World has done so much work on the identity and now, doing solid privacy with biometrics and everything. But, what is the view from World about, like, for instance, Cello, the team came out recently with self-ID that scans the RFID and passports. Like, are you guys going to follow a multifactorial approach at some point? Just kind of wondering.
Right. Self is the team that was called Open Passport before it was acquired by Cello, right? That one.
Probably, yeah.
Yeah. So this is in general like what I've seen. Like there's a bunch of teams that are doing these selective disclosure proofs of your identity, like KYC identity in this case. I mean, where you have some signed credentials, like your signed passport or your signed electronic ID, and you can create proofs of like I'm of age, I'm of that, or whatever. The thing with these products is that we have a different set of constraints than most other people building these products, because we have an existing user base of over 25 million people, and if you look at the distribution of devices that these people run, they can be like really low-end devices, right? If you look at the bottom end of like devices in like Latin America, Southeast Asia, and other places, these devices run like 32-bit Android phones from 2013 with 2 gigs of RAM, and if you want to do ZK on that, it's really hard. So what we've been doing over the last year is, instead of like doing it the Apple way, if you will, like instead of rolling out a product that works fine for the top of like user devices like iPhone 16 Pro Maxes and like the sort of flagships for over the last 2 years, we've been building up foundation cryptography to actually do this thing like client-side. It's called client-side proving, so that you're able to do proving in low-end powered devices, and all of them have this like really like low benchmark capability of like actually doing computation. So right now we've been mostly focusing on the foundational cryptography. I'm actually going to be giving a talk about that at ETH Seoul over the next couple of days. So once we've solved that, then we're able to roll out this World ID credentials with selective disclosure. Right now, all we allow you to do within World ID credentials is for a select group of countries, including South Korea. You're able to prove you own a unique passport, but you cannot do selective disclosure just yet, because that requires a lot more cryptography to be run on device. But yeah, this is our general strategy, right? Like building the foundational cryptography that then is powerful enough to actually distribute the product. It's not enough to actually build a theoretical solution or even a practical example, but to actually solve the problem, you need to have it so that all of the users around the world, like billion+ people, can actually use this thing. So this is sort of what we've been focusing on.
All right, thank you.
Awesome.
Thank you.
Thank you so much.